Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to continue going over the titration of a strong acid with a strong base. So where we left off was the pH after adding 25 milliliters of our NaOH solution. So we were at the equivalence point, and so we had decided that because we had added 25 milliliters, we know that that's the same number of moles of NaOH that's needed to neutralize this strong acid. So we neutralized the acid, no more acid, all of the OH minus is gone, all of the H plus is gone, so what's left is water. And so the pH of the solution is now the pH of water, and we're assuming 25 degrees Celsius. So at 25 degrees Celsius, the pH of water is 7. So we have two more things to look at. The next one is to calculate the pH after adding 30 milliliters of NaOH. So at this point, we're beyond the equivalence point. So anything we add now is going to be excess OH minus. So we're dealing with a strong base after the reaction. So again, with our table, we can do our table again. So before adding anything, we said that the number of moles of H plus is 0.0025 moles. And we don't have any OH minus, so our hydroxide ion is effectively 0. And then we're not caring about the water. And so at this point, we're adding 30 milliliters of our NaOH. So to calculate the number of moles, so we calculate the number of moles again. So at that point, it's going to be 30 milliliters is the same as 0.030 liters of our NaOH solution. So this is our NaOH solution. And then we can use we're going to use the molarity of the NaOH to convert to the volume. So we can do that. So this is going to be 0.100 molar. So let us do that. So this is going to be liters on the bottom. So 0.100 moles of the NaOH. And again, we have 1 liter of NaOH on the bottom. So liters cancels out. And this is the number of moles. So we can calculate 0.1 times 0.03 is going to be 0.0030 moles of NaOH. So H minus, NaOH. So this is the number of moles that of our NaOH is added. So we can write that down here. So this is going to be 0.0030 moles of our OH minus concentration. So we're not adding anything there. And so once again, this is the number of moles of our OH. This is going to react completely with the H plus concentration. And you can see at this point that we have more moles of our NaOH versus our H plus. So instead of having H plus left over, we're going to have OH minus. Our hydroxide ion is going to be left over. So we'll have OH minus instead of H plus. So this we have less of, and because this is a strong acid, strong base, it's going to react completely so that H plus is gone. So now the 0, so H plus is effectively 0 at this point. So we lost, so this is going to be minus 0.0025. So that means we're subtracting that amount from here. So if we subtract 0.0025 from here, we end up with 0.0005 moles left of our HO minus. So we have our hydroxide ions. We have 0.0005 moles of OH minus. So now at this point, we have to calculate the concentration of OH minus that's left over. So we can do that. Again, we have to calculate the new volume. So we added 30 mils of our NaOH to 25 mils of the HCl that we started with. And so the total volume when we add 30 to 25 is going to be 55 milliliters, or 0.055 liters. So that's the new volume. So to calculate the concentration, we're going to take the moles here and divide by the volume. So it's going to be 0.0005 moles divided by 0.055 liters. And our new concentration, when we calculate that, is going to be 0.0005 divided by 0.055 equals, and so therefore our new concentration, the concentration of OH, is going to be 0.0091 molar. So this is equal, that's the equal to the concentration of OH minus. So now we have the concentration of OH minus, but we want to figure out the pH. We need the H plus concentration. So we know that the H plus concentration multiplied by the OH minus concentration is equal to the Kw, which is 1 times 10 to the negative 14. So we know this, so we can divide both sides by the OH minus concentration, which is here, and we can get the H plus. So we can take we'll take 1.0 times 10 to the negative 14, and we're going to divide that by 0.0091 and equals, and so that's going to give us, so the H plus concentration is equal to 1.099 times 10 to the negative 12. So then all we need to do now is take that number and find the negative log of that number to get the pH. So we take the negative log of that number. So that number, negative log, and the pH is 11.96. So it goes up to 11.96. So the pH, pH is equal to 11.96. And so here at 30 milliliters, the pH goes up to 11.96. So that's really close to 12 here. Okay, so you'll see that the pH rose quite a bit. So here, you can see now after the equivalence point, the pH still goes up. And so that is the calculation at 30 milliliters. And so again, I want to reiterate that after the equivalence point, this is a strong base problem. So anything you add of the strong base, you're going to have strong base left over. And so at the end, you are going to be doing the exact same calculations. So for example, when you're doing the pH at 35 milliliters, you calculate, again, you use the 35 milliliters and the molarity of the NaOH, and you calculate the number of moles of your OH minus that you added. And then again, you would add that to your table and then subtract it, since again your H plus is going to be less than the OH minus you added, then you're going to have a certain amount of OH minus left over. So you would then use that, find that amount that's left over, and then calculate the new volume. So again, if you're adding 35 milliliters, then that's going to be added to 25, and then that's going to be, instead of 55, you're going to have 60 milliliters, and then you use that to find the concentration. So whatever moles you have of your OH minus here, you're going to divide that by the new volume. If it's 35 milliliters, then your total volume will be 60. So just like we did here, so instead of 55, whatever this moles is going to be divided by 60. You find the molarity of your OH minus. Use this to find the H plus. You know that the H plus concentration multiplied by the hydroxide concentration is equal to Kw. And then you can find the H plus concentration. And then from there, the pH is equal to the negative log of the H plus concentration you find. And so I did that already. So the answers there for 35, 40, and 50 milliliters of NaOH added, the pH then becomes 12.22. So we have 12.22 for 35 milliliters. And for 40 milliliters, it's 12.36. 12.36. And for 50 milliliters is 12.52, so 12.52. So for those, we can add in our points here. So 12.22, so that's going to be maybe about there. And then for 12.36, maybe it's about there. And for 12, and then it's 12.52, so we're about here. And so on. And so you can see here that the graph shows kind of an S kind of graph here. So if we connect the dots, here, then you'll see an S-shaped curve, which is typical of your strong acid, strong base problem. So this is a typical curve for when you're taking a strong acid and you're titrating it with a strong base. And so this curve is really important because here at this end, you've got H plus is what is dominant. So that you're always going to have an excess amount of H plus at this point. At the equivalence point, you don't have any excess H plus or excess OH minus. So then the H plus concentration is due only to the water autoionization. So that's going to be a pH of 7 for water. And then if after the equivalence point, you're going to have an excess of OH minus in this part. So you figure out what the OH minus concentration here at this part is, and then you find the pH for here. So this is excess OH in this area, excess H plus in this area, and here it's neutralized and you have neither, so pH of 7. So for the graph here, for strong acid, strong base, it's always going to be a pH of 7 at the equivalence point. And so if this was a different problem, let's say if instead of a strong acid with being titrated with a strong base, let's say we had a strong base being titrated with a strong acid, it would be the exact same steps. The only difference would be that instead of starting at a low pH, because we're starting with an acid and titrating with the base by adding the base, we would start with a high pH here, and because we would be starting with only base in our Erlenmeyer flask, and we're adding strong acid to that. So as we're adding the acid, we start at a high pH, and as we add the acid, the pH would decrease. So this would be flipped by 180 degrees. So you get the mirror image of this graph here. So instead of starting down here and going up through 7, pH is 7, and then plateauing, we would be here and we would go down, go through 7, and then plateau this way. And so you get the mirror image of your S graph here. And so that's titrating a strong base with a strong acid. So I hope this video is helpful. If you enjoyed this video, if you learned from this video, if this video helped you in any way, please like the video, hit that like button right there, and also subscribe to my channel, help me out. Hit that notification button up there so you can be notified by other videos I put out. And also put a comment down in the comment section. Let me know what you think. If you have any questions or comments, I'd love to hear them. Thanks for joining me. Have a great day.